In this video, I'm going to do a couple of subspace examples. So in this first example, I've got the following subset of R3. Now, I'm told that the third component is the first component plus 2 times the second. So actually, the first thing I'm going to do is rewrite this so that the set's a little easier to work with. So I've gone ahead and rewritten that because I know that that third component has to be x plus 2y, so I was able to get rid of the z. Now, I want to show this is a subspace of R3. So I only need to prove 3 things. Now, the first thing is clearly the 0 vector. So the 0 vector in R3, that's it. And we know that that is an element of W, right? Because the third component is equal to the first plus 2 times the second. Next, I want to show that it's closed under addition. So I'm going to take 2 arbitrary vectors in W and show that their sum is in W. So there are my 2 vectors, V and W, which are both in the set W. So what's V plus W? Well, V plus W is equal to x1 plus x2, y1 plus y2, x1 plus 2y1 plus x2 plus 2y2. And I want to make it a little more clear that that's in W. So I'm going to rewrite this in the following way. This is y1 plus y2. And the last component is x1 plus x2. And I can pull out that 2. So I have 2y1 plus y2, and that makes it very clear that this last component is the first component plus 2 times the second component, and so I can conclusively say that this is indeed in W. So it's definitely closed under addition. The last thing I have to do is I need to show that it's closed under scalar multiplication. So for that, I've taken a vector V in W and a scalar, and we're taking our scalars from the reals. And I need to show, and I call my scalar alpha, we need to show that alpha V belongs to W. Alpha V is alpha X, alpha Y, alpha X plus 2Y. And let's make it a little more clear that that belongs to W. So I'm going to rewrite it as alpha X, alpha Y, alpha X plus 2 alpha Y. And that definitely belongs to W because the third component is the first plus 2 times the second. So that's in W. So we've just shown that W is a subspace of R3. Next, I'm going to consider this subset of R3. So here I have that the second component is the product of the first and the third. So as an example, if the first component was 2 and the last component was minus 1, then the second component has to be 2 times minus 1, which is minus 2. That is an element of W. Now, the first thing I like to think about is, does this contain the 0 vector? And indeed it does, right? The 0 vector is in W. And in fact, this isn't a subspace. So the next thing I like to think about is scalar multiplication, because it's often easier to work with. So is it closed under scalar multiplication? And I can kind of see that if I took a scalar and I multiplied it by, say, that vector that we just did, that I might not end up being back in W. And remember, to show that it's not a subspace, you just need to show that one of the properties is not satisfied for a specific example. So let's go ahead and do that. Let's take V to be that vector that we just worked with, 2, minus 2, and minus 1, which is in W. And let's take alpha to be, say, 3, okay? So then alpha V is equal to 6 minus 6 and minus 3. Now, 6 times minus 3 is minus 18. And that second component is not minus 18, so this is not in W. So we can say that W is not a subspace of R3.